Over the past few years, as the application of 3D printing has increased in fields like biomedicine, optics, and soft electronics, efforts to develop high-resolution 3D printing technology have also gained ground. One of the most recent developments is melt electrowriting, a technique by which a molten material is pulled from a nozzle by a strong electric field into a thin jet. Such jets are much thinner and faster than those of other techniques, where a material is simply extruded from the nozzle. Material deposition along a predetermined printing path was previously used to print structures by vertically stacking layers. However, that limited the range of possible printed geometries. Now, with a novel technique developed by scientists from Germany and Spain, the true potential of melt electrowriting can be unlocked. It is known that printing above a certain speed causes jet lag. That is, the melt hits the collector surface a slight distance behind the nozzle, resulting in deformed structures. When printing sinusoidal waves at such speeds, the jet lag causes the stacks to become tilted as layers are added. The scientists found that they could accurately control the direction and magnitude of this tilting by introducing very small changes in the printing path of each layer, thereby deciding not only the geometry but also the mechanical properties of sinusoidal prints. They call their technique microscale layer shifting because they deliberately use these shifts in printing path to control the layer-on-layer positioning. Their approach even allows the horizontal stacking of layers without any support structures. With this technique, they can print complex nonlinear geometries applying both smooth and abrupt changes in printing trajectory and achieve wall texturing and branching. This study demonstrates the possibility of producing a great variety of novel scaffolds with different pore shapes and sizes and fine-tuned characteristics, which promise to have a profound impact on the development of products in a broad range of applications.